If you want to write assembly language programs and you want to see how a computer takes that code and actually runs it, then this is the course you want to take. I have generated a 16-bit computer. We also have a graphics and a display card and a keyboard, and I've brought all of the registers here out onto the top level. So let's actually drop into the computer and see what we have. So you can think about this level as being the motherboard of your computer. We're going to have some I/O cards here, and you can see we've got a keyboard, display and two graphics cards at the moment. We've got a ROM here which contains our BIOS, all of our library functions and subroutines. We have a RAM which we use to load up the programs which we can write. And we have our CPU. So let's drop into the CPU. So in the CPU, we have an arithmetic logic unit, we have a control section, we have a memory address register, instruction register, and instruction address register, and we have all of the registers along the top here, including an index register and a stack pointer. So let's drop into the control unit. Now within the control unit we have a little counter here. We have a whole load of enables along the left hand side and sets along the right hand side, and those are controlled via a microcoded ROM, and this is our microcoded ROM here. Now let's load up a program and actually see it working. I write all of my code in Visual Studio Code Editor. Now if you take the course, I will show you how to set this up exactly the way that I have it here. So let's say for instance if we want to add two numbers together, we can get into this file here, add.asm, and you can see here what we have is the assembly language code to add two numbers together. Now it doesn't matter if you don't understand this just now, it's all explained in the course. You can also write your own code and run it on the machine. So we want to take this code here and we want to generate the machine code. So we can go to terminal, run task, assemble file. So this runs through our own assembler and it generates the machine code. So if we drop in here, we can see the machine code. And this is the machine code here that will allow us to add the two numbers together. So let's take this machine code and load it into our machine and see it actually working. So this is our machine here. We go to the computer, we right click, edit contents, open, and we open our file which is add.mc. And you'll see that the code is now in the RAM. So we can go to the desktop here and then we can run it. Now it's going to put the number 5 in register R0, the number 3 in register R1. It's going to add the two together and put the answer in register R1. So we can go simulate, tick enabled, and you'll see that's it, finished the code, and you can see we've got the end here. We've got 5 in here, we had 3 in here, we added them two together and we got a number 8. So this allows us to run the code. Now if we wanted to, we could go simulate and we can load the code back in again, reset, reset, and we can actually jump through the code one step at a time. So if we get into the user panel, and I can click through one single clock pulse at a time, and we can see the actual machine running. So at any point in time I could drop down in and I can have a look and I can see exactly where the machine is and what state it is in. Now if I want to, I can also run it very slowly, so I can go tick frequency and I can put the tick frequency very low and I can go simulate tick enabled, and this will tick through, and as it ticks through we can drop into the machine and we can watch every single pulse that generates in order to make the code run. So if you're interested in assembly language programming, you're interested in computer architecture and organisation and design, and you want to understand it all fundamentally from the bottom up, then this is the course that you want to take. You will not get another course like this. It just doesn't exist. So crack on, sign up, and let's get started.